So we're switching our focus into solving radical equations. And what you will see is we're walking you through an example here, and the equation is given. And basically the first step you always do is isolate the radical. So there was a 2 over here, okay, and that was outside of the radical, so they have moved that 2 over to the other side so that the radical is isolated. That means nothing else is over there on that side with the radical. And then you want to raise both sides up to the same power as the index. Okay, so our index in this particular equation is 2, so this is a square root. So let's see, remember square roots have an index of 2. They don't write the 2, but it's understood to be there, right? So if you have a square root, you can think about that as the second root, right? If you have an index of anything but 2, they will have to write that. So if you have an index of 3, they're talking about a cube root. Index of 4, they're talking about a fourth root. So it's always understood to be an index of 2 unless they say otherwise. And so you can see here where they have raised both sides to the second power, or they have squared both sides. Then you have to carefully work through your algebra. All right, so a lot of students make a mistake here. All right, so you've got to remember that when you have a binomial squared, that's a binomial times itself, and you need to use your FOIL process to multiply this out. Okay, and then you will get this outcome. All right, and then on the right side, this square cancels the root. So this square cancels the square root out, and you are just left with the x plus 10. And then you have a quadratic equation that you have to solve. So you want to get it set equal to 0. And then you want to either factor or quadratic formula. In this case, obviously you can see they use factoring, which is much easier. And then you set each factor equal to 0, and then you solve for your x solutions. So one thing that you have to be careful with here is being mindful of these domain and range restrictions that we were talking about when we discussed the graphs. So for this particular equation, you want to plug in each of these solutions to make sure they actually check. And if one of them is not checking, then that's going to catch one of those domain or range restrictions that you might have going on. So when they over here, they have taken the x equals 6 and they have plugged it in and worked it down. And if you're getting the left side equals to the right side, which in this particular one here, you are getting that 6 equals 6, and so it checks. Okay. When they plug in the -1, you can see that you get down to a situation where the left side does not equal the right side. The left side is -1 and the right side is 5. So these are obviously not the same, and so it does not check. So when you give your final answer, you can only include the value that actually checked. And once again, that's all kind of going back to that domain and that range situation that you're dealing with when you're working with radical functions. So as you continue with your work here, just be very careful of your index. So I wanted to point out in this problem here, they're giving you an index of 3. So instead of squaring both sides, you want to raise both sides to the third power. So you always use the same exponent as your index. And just a few other little tips: make sure you're always isolating your radical. So like in this first problem here, the first thing you want to do is divide both sides by 10, and so you can get that square root of 9x by itself. As you get down to other problems here, the first thing you want to do is get rid of this +2. So you want to subtract 2 from both sides, and that will isolate that radical and then carry on from there. When you have a problem written like number 6, this exponent here, this is just a different way to write a square root. Some of you may not remember this. This is considered a prerequisite skill, but that does mean square root of 2x plus 1 equals 5. Okay, and then if you go down to the challenge problems here, All right, you will see down here they have an exponent of 2/3. All right, so I wanted to help you get started on that one. That one is actually the cube root of 3x plus 4 squared. All right, so when you have an exponent of 2/3, it is equivalent to the cube root of 3x plus 4 squared. And over here you have on the number 1, you have a radical on both sides. All right, so that's a little bit of more of a challenge, and you have a lot of algebra you have to get through to do those, but give it a try and see how you did. And from then on, from here on out, just make sure you're showing all of this work. Okay, we are giving you the final answers on the answer key, so I know you already have the answers. All right, I'm looking for all of the work. All right, so show your work. If you only write down what's on that answer key, you're going to get 0 credit because I already gave you that answer, okay? I want to see all the algebra to support that. I'll see you in the next video.